On this video, we're going to solve trig equations. So you have cosine x equals 1 over 2. We need to find cosine of what angles will equal to 1 over 2. Well, if you know that cosine is positive in first and fourth quadrant. So going back to your unit circle, cosine of what is 1 over 2? Well, that's when x equals pi over 3. If the reference angle is pi over 3, what is this angle right here? That angle will be 2 pi minus pi over 3, which will be 5 pi over 3. So you have two solutions, right? Pi over 3, 5 pi over 3. But if you think about it, we have more than two solutions because you could go around 360, 2 pi, and you could keep going like that. Also from here, you could also go from rotate 2 pi, and 2 pi, and 2 pi, and so forth. And you could go the other way too. So you could go clockwise or you could go counterclockwise. So you could go counterclockwise or clockwise from pi over 3, and you keep rotating 2 pi, so it will be 2 n pi, and you could say you could keep doing the same thing for 5 pi over 3, so plus 2 n pi, this is pi, where n is any integer. So this is what I mean. If n is 0, right? If n is 0, then this whole thing becomes 0. So your solution is pi over 3. What if n is 1? If n is 1, this becomes 2 pi. So you get 2 pi plus pi over 3. If n is negative 1, this will become pi over 3 plus negative 2 pi, and so forth. So basically, you have infinite number of solutions for these problems. Let me explain it graphically. So when you graph y equals cosine x, which is a red graph, and y equals 1 over 2, basically we're trying to find the intersection points. Now notice, you see 1, 2, 3, 4, 5, 6 intersection points. But as this graph keeps on going, you'll notice that you have infinite number of solutions. So that's why we need 2n pi. Let's take a look at this example. So you have 4 sine x equals 2 sine x plus radical 2. So you want to solve for sine x first. Let's subtract 2 sine x both sides. You get 2 sine x equals radical 2. You divide 2 by both sides, you get sine x equals radical 2 over 2. Now sine is positive in the first quadrant and the second quadrant. And what's that angle right there? Sine of what is radical 2 over 2? That's when x equals pi over 4. Then what is this angle right here? Well, that is pi minus pi over 4, which is 3 pi over 4. Again, these two are not just the solution because you have infinite number of solutions here. And let's think about it. What is a period for sine x? That's 2 pi. So you have to do 2 n pi plus 2 n pi, where n is any integer. And at this time, you want to probably graph both of them and see how many intersections you get. And you'll notice that you will get infinite number of intersection points. Let's take a look at this example. 2 tangent x minus radical 3 equals tangent x. Now, before I start, do you remember the period for tangent x? It's not 2 pi, it was pi. Period for tangent x is pi. And we will need this information later on. So how will you solve for tangent x here? Well, let's subtract tangent x both sides. You get tangent x minus radical 3 is 0. And we want to move negative radical 3 to the other side. The tangent x is radical 3. Now, tangent x is positive the first and the third quadrant. And what is the tangent of what is radical 3? Well, it's pi over 3. Now notice, what about this angle? That angle is pi plus pi over 3, which is 4 pi over 3. Okay? Now notice, from here to here, all you needed was pi. Now how do you get from here to here? You also need pi. So basically now, what was the period for tangent? It's pi, right? So instead of 2n pi, now you have to put n pi. Okay? Again, we have infinite number of solutions here. But now, what's interesting is this. What happens when n is 1? When n is 1, you get pi, and pi plus pi over 3 is 4 pi over 3. So you don't actually need this. All you need is this portion right here. And you might want to graph these two and see how many intersections you get. Let's take a look at this example. 4 sine square x plus 1 equals 4. So in order to solve for sine x, you have to subtract 1 both sides. And then divide by 4. And you have to take the square root. So when you take the square root, you're going to get sine x equals positive negative radical 3 over 2. Now don't forget, be careful with the positive and negative. So now this means that you're going to have sine x equals radical 3 over 2 and sine x equals negative radical 3 over 2. Let's solve this part first. You know that sine x is positive first and the second quadrant. So sine of what is radical 3 over 2? Well, that's going to be x equals pi over 3. If this reference angle is pi over 3, what is this right here? That's pi minus pi over 3, which is going to be 2 pi over 3. And you have to do plus 2n pi and plus 2n pi where n is any integer. What about this part? Sine x equals negative radical 3 over 2. Well, you know that sine is negative in third and fourth quadrant. So what is this angle again right here? I mean, the reference angle is pi over 3. So that angle is pi plus pi over 3, which is going to be 4 pi over 3. And plus 2n pi. And what about this one right here? Well, that's going to be 2 pi minus pi over 3, which is going to be 5 pi over 3 plus 2n pi. So you have, make sure you put all these 4 for the solution. Okay, let's take a look at this example. Cosine x, sine x equals 3 cosine x. And now we have a restriction. So the answers you get has to be from 0 to 2 pi, where you include 0, but you don't include 2 pi. So now, this is where the common mistake will happen. Some of you are going to divide both sides by cosine x, and thinking that you're going to get sine x equals 3. But when you do that, first of all, this is not mathematical, because when you do that, you lose one of the answers. So please be careful not to divide by the variables. So instead, what you need to do is you want to move this term to the other side. And then take out the common factor, which is cosine x. We get 3 minus sine x. So now what you do is 0 equals cosine x, and 0 equals 3 minus sine x. Now cosine of what is 0? Well, that's when x equals pi over 2 and x equals 3 pi over 2. Now notice, you don't need 2 and pi anymore. Why? Because you have the restrictions now. And notice, pi over 2 and 3 pi over 2 are within the restriction. Now let's take care of this part. So I'm going to move sine x to the other side. Sine x equals 3. Now think about it. Sine of what is 3? If you remember the graph of sine, the highest value that it goes up to is 1. Sine x can never equal to 3. So this is no solution right here. So only solution you have is pi over 2 and 3 pi over 2. Okay, let's take a look at this example. Cosine to the 4th of x plus cosine square x minus 2 equals 0. Again, we have the restriction, 0 to 2 pi. Before we do this, do you remember how to solve x to the 4th plus x squared minus 2 equals 0? Do you remember how to factor that? Well, it's going to be x squared plus 2, quantity x squared plus 2 times quantity x squared minus 1. Okay? We're going to use the same idea here. So it's going to be, when you factor this out, it's going to be cosine square x plus 2, and then cosine square x minus 1 equals 0. So now you get cosine square x plus 2 equals 0, or cosine square x minus 1 is equal to 0. So cosine square x equals negative 2, and when you take the square root, your cosine x equals positive negative radical negative 2. Now think about this. What is square root of negative 2? That's not real. This is not a real number, imaginary. So there's no solution to this part. What about this one? Cosine square x equals 1. So cosine x equals positive negative radical 1, which is 1. So this means cosine x equals 1, or cosine x is equal to negative 1. Cosine of what is 1? Well, that's when x equals 0, and 0 is within the restriction. Cosine of what is negative 1? Well, that's when x equals pi, and that is also within the restriction. So you have two solutions. And you might want to graph this and find when this whole thing is equal to 0. And you'll notice that happens when x equals 0 and x equals pi. Let's go ahead and solve our last example. 2 cosine square x minus sine x minus 1 equals 0. And we have a restriction. Notice, this has both cosine x and sine x. And when you solve trig equations, you want to make sure that equation has one common term, meaning that either, yes, everything has to be in sine x, or everything has to be cosine x. So if you remember from Pythagorean identity, you have cosine square x plus sine square x equals 1. So what is cosine square x? That's 1 minus sine square x. So using substitution, substituting 1 minus sine square x, and simplifying by distributing the 2 and adding the like terms, you get this. I don't like the negative, so I'm going to multiply everything by negative. You get 2 sine square x plus sine x minus 1 equals 0. Do you remember how to factor 2x squared plus x minus 1 equals 0? If you recall, it's going to be 2x plus 1 and then x minus 1. So using the same idea, we're going to end up getting quantity 2 sine x plus 1, quantity sine x minus 1. Hold on, let me check whether I did it right. I made a mistake right here. This should be minus, and that should be plus. Okay, so this should be minus. And that should be plus. Okay? Because when you multiply it out, the middle term should be sine x. So when you solve this, you're going to end up getting sine x equals 1/2, or sine x equals -1. Now, let's do this first. Well, sine of what is -1? That's when x equals 3 pi over 2. Now, sine of what is 1 over 2? That happens when the angle is in first or second quadrant. So x equals pi over 6, and x equals pi minus pi over 6, which is 5 pi over 6. So you will have 3 solutions, and they're all within the restriction. So now what I want to do is, you got to be able to solve this type of problem using calculator, as graphing calculator as well. So this is a good time for you to practice graphing calculator. So when you graph it from 0 to 2 pi, you end up getting this. Make sure when you plug in the equation, this is how it should look like. Okay? And when you graph it, make sure your zoom, window goes from 0 to 2 pi, because that was our restriction. Now let's go back to our graph. How do you find the x-intercepts here? Remember how do you find the x-intercept? Let's do one of them. How do you find the x-intercept of this? Well, you have to go to second calc, second trace, and you have to press 0 since you want to find the x-intercepts. If you want to find the intersection, you got to use number 5. But in this case, we're solving for x-intercepts. We're going to press number 2 for 0. So let's say you want to find the x-intercept right here. You got to find your left bound. So move left side, press enter. And right bound, move the arrow to the right side of the x-intercept. Press enter, and then press enter again. And there is your x-intercept right there. And you got to do that for these two. Repeat the process to find these two, rest of the two x-intercepts.